All right, looks like we're up and running here. Uh, Make sure you can see the board here. Okay, so this video is going to be talking about a variety of new topics that we'll be tackling for the rest of the semester. So I'm gonna introduce factoring, sum and difference in two cubes. I'm gonna talk a bit about the differentials involved in exponential functions. I'll derive the quadratic formula for you. Absolute value is now going to be something that we're going to start looking at, and we're going to define it as piecewise functions to help us solve equations and inequalities. And I'll define a couple of trig functions, get us started with a little trigonometry, which people have, the beginning type questions, a lot of success with. So it won't take you long to pick up on those. We'll have at it. So this is just the lecture I'm going to give in a few hours. And so you don't have to take notes because you can replay this. All right, so I've already written the difference of two cubes. Hope you recognize 27 and 8. And really it comes down to this material was certainly looked at from a geometric perspective at some point. So how are we going to work with those cubics? We're going to talk about cube roots. So what's the cube root of 27? 3. What's the cube root of 8? 2. So you start with the cube roots. If it's a subtraction problem, it remains a subtraction symbol in the first parentheses. And then it's your job to figure out how you can look at these numbers to get the 3 subsequent numbers in the second parentheses. 27 minus 8 is 19. 3 minus 2 is 1. 9 and 6, 15, and 4 is 19. So this subtraction is now written in terms of multiplication, which can help us if we're dealing with some division problems, simplification, inverse operations. If it had been addition, then this becomes addition. And just this one middle term changes signs. So how do we get 3? We have to recognize the cubic. We have to recognize the sum of two cubes or the difference of two cubes. This, of course, becomes 27 plus 8, which is 35, I believe. And that certainly is 5 in the first parentheses, and 3 plus 4 is 7. And oh yeah, 5 times 7 is 35. So not only did it work for the subtraction, but it worked for the addition. So if we talk about any number, x cubed minus y cubed, difference of two numbers that are, we can make them cubics. Any subtraction can be made into a cubic. Problem. I can tell you, if the volume of a cube was 2, then you work with the cube root of 2. The volume of a cube was 7, then the cube root of 7. And you could add those cube roots and do the pattern on the right side. But subtraction, I hope we can see, take the cube roots. We square the first term, which is always positive. We square the last term, which is always positive. Some people make mistakes here quite often. When you square numbers, you get positive at the beginning, positive at the end, and whatever that product is, you change the sign. Now I'll do this out one time. X times x squared, x cubed. So I'm putting an x. I'm putting an x with everything. X, y. Putting an x with that. I'll keep it in this order. Then I'm doing a y, minus y squared, x. Where am I? Minus x squared y. Yeah, okay, minus x squared y. Did I miss? Oh, I did it. That's y. I did that poorly. X times x, y is x squared y. So I knew I had a little error. Now minus x squared y, minus, where am I? Minus xy squared. And minus times a positive is a negative at the end. Y cubed, and so the middle terms cancel. And waking up here still. And there's my x cubed minus y cubed, bringing us back to the beginning. Okay, all right, and they're gonna get tougher. We're gonna do some, let's say 8y to the 6th plus, let's keep that x. Let's keep it x, and let's add, let's just keep it simple at this stage. All right, so what's the cube root of this? Cube root of this is equal to 2 cube root is the same thing as saying 6 divided by 3, right? That means cube root. So 3 goes into 6 twice, so that's the cube root. And that we've already worked with, so that's our first parentheses. So that has to get squared. 4x to the fourth, right? There's your 2 and 4 make 6. And then we have the product, but we have to change the sign, so that's simply 2x squared y. And then we have to add y squared. And if you multiply that out, middle terms cancel. So 4 terms cancel. All right, so that gets us started. The conversation has started. You'll see it on every worksheet, the rest of the term. Now I have a little more space to work with. I already did 27 plus 8. Now I'm talking about differentials. So let's say you have an exponential function with these bases. Then you should be able to do the following with ease. Now, what did I just do? I wrote this as 4 over 1. All right, and this is your first differential from left to right. Something's going to go up 1 unit. Something else is going to go up 4. If this had been 10 units, then that would have been 40. But in this case, we're only looking at a 4-to-1 ratio. So this differential is 4 times the one that precedes it. And if you don't see a constant, then that is your asymptote. All right, now where's the asymptotic behavior? As x goes to negative infinity. All right, for instance, 4 to the minus 10 is 1 over 4 to the 10th. And that, my friends, is very close to 0 on the left, as an example. All right, so you try the next one. All right, so what do we have? We actually have a 7-to-1 ratio. 7-to-1 ratio. Right? And nothing else different, still 0 if it's not been, because exponential functions are a b to the x plus c. Unfortunately, most textbooks start with a b to the x, and then they add c a little later in the problems that they ask, but that is what an exponential function is, and yet you're given the impression that it's just asymptote is 0. Okay. So what do we have over here? We have slightly different. Still, it's 2 over 1. So we're back to what? No constant. So boom, 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 boom. So I have a 2-to-1. And what have I introduced? That's a little bit different. A ratio of 2-to-1. I've introduced, how often does that happen? I don't know, every 7 minutes, every 7 days, every 7 seconds, something, whatever unit measurement you're in. This really is all about the time elapsed for that 2-to-1 to occur, which means any function can be written as a doubling function. You just have to find 2 differentials that are one that's twice the size of the previous one, and then just look at the elapsed time it takes. Now, the last time I remember something in the news quite frequently was the rate at which people were getting sick from COVID. And it was not very good situation because we had time, and I think it was like every 3 days at one point, the number of people getting sick was doubling. Well, that's going to be at some point a very rapid increase in how many people are going to be sick, which is why folks were talking about leveling off that curve. Right? So anyway, that was just a quick statement on my part. And now we're going to look at this one. So let's look at 1/3 x over 10. All right. The denominator is your first differential. And then your next one is in the numerator, your second differential. And this particular one, I added 9. So our constant is 9. Well, that gives us 3 y values. One that we can see immediately, another one that is 12, and another one that is 10. The question is, can you spot what x's you have to use to make that happen? Well, you got to consider something to the 0. 0 divided by 10 is 0. And what is 1/3 to the 0? There's no difference in the numerator than the denominator in terms of how many times you see 1/3 as a factor. There is no difference here. And what is something divided by itself? The number 1. So we want to make our exponents equal 0 because it's really easy to multiply by 1. And so going back to the original, if I put a 0 in there, then I get, oh, I want this one here. Yep. So I get 1 plus 9 is 10. And when does that occur? When that's 0. All right, which means that we need negative 10 now. In order to get this, right, we need a number smaller than 0. And in this case, negative 10 divided by 10. Negative 10 divided by 10 is negative 1. Negative 1 flips the 1 over 3. And I get 3 plus 9 is 12. Okay, so that occurs at negative 10. And if you wanted to put in positive 10, that's fine. It's just that this one is 1/3 the previous size. You can see the exponential decay. Okay, all right, so that's a topic that we're going to continue to explore. Nothing new except trying to deepen the conversation. You know, looking at these exponential functions and hopefully getting a deeper understanding. I hope that that gets that conversation started. Let's see what I got on the back side. Okay, I derived the quadratic formula, a rite of passage. A rite of passage for every algebra student. Everybody pushes the quadratic formula. I find it to be cumbersome. That many times it's quicker and easier to work with other aspects of solving, but it's there to help us solve ax squared plus bx plus c equals 0 equations. Okay, so setting something up, if you can't factor it, if you can't use inverse operations, if you can't see the roots from a graph, then you work with the quadratic formula. It's useful. So we're going to learn how to memorize it using different letters, and then we'll work with it with numbers. But we got to get the conversation started, so we're starting it. So if I knew that the vertex of an exponential of a quadratic is x equals 4, then I write x minus 4 squared. We've been working with minus b over 2a now for 5 weeks. So if I want to write the parentheses aspect of a graphing form, and I know x equals minus b over 2a, then I'm really writing x plus b over 2a squared. Because when I substitute minus b over 2a, I get 0 squared, and that's the smallest amount you can get out of squaring is 0. Right? Every other square is positive. Square a positive number, it's positive. Square a negative number, it's positive. Square 0, it's 0. 0 is smaller than positive numbers. If I put a negative in front of the parentheses, then it's going to be the biggest number. All right, so I start, and our goal is to get ax squared plus bx plus c into the ax minus a squared plus k format. And solving that for 0 is easy. Minus k over a plus or minus the square root of that plus h. Piece of cake. You can see it in 5 seconds or less. Okay, so let's get started. X plus b over 2a squared, I'm multiplying that by a just to get started. And if I put a 0 in, if I put a 0 into this function, right, those two terms cancel and I get c. So I know that f of 0 has to get me c. Right now I've got, when I drop a 0 in, I've got a times b squared over 4a squared. Of course, I can cancel one of the a's, which gets me b squared over 4a. That is not the letter c. So I have to get rid of it. What I created, I have to get rid of. That's all about completing the square. All right, we've shortcut that process by working with minus b over 2a. But I need c, so I write c. Now that is equal to this. All right, so we have to now solve this equation for 0. Let's do it. So the first thing I do is positive c becomes negative c, negative becomes positive on the other side. I can see that I can divide by a right now. If I do, I get c over a plus b squared over 4a squared. And I'm dividing each of those terms by a. All right, I decide to rewrite it as b squared minus 4ac. I hope folks can see that I need a common denominator here. So I'll multiply by 4a and I'll multiply by 4a, and I'll bring that minus sign back. So that brings me to b squared minus, yeah, you can see all that, minus 4ac over 4a squared. What's the next step? Okay, I didn't write that out yet. So right now we're at x plus b over 2a squared equals b squared minus 4ac over the common denominator. Now I have a common denominator, 4a squared. I'm going to have to use the eraser here. So I am going to, well, maybe not yet. X plus b over 2a equals plus or minus the square root of b squared minus 4ac. And to save some space here, to save a little space, I'm going to take the square root of the denominator. Hope people can see that that's 2a. And now I'll use a little bit of eraser here. I am going to make this go to the other side, which makes it negative minus b over 2a. So that these are my x values, minus b over 2a. I'll move this a little bit centered. Plus minus the square root of b squared minus 4ac all over 2a, which means that both of these terms are divided by 2a. So I'll erase and divide both terms by 2a, and that gives me minus b plus or minus the square root of b squared minus 4ac over 2a. All right, because this is a video, you can go back to the beginning. You can try to do it yourself. It's good practice, good algebraic practice. And like anything else, if you want to get good at something, you got to practice. So if you're used to going to the gym and lifting weights, maybe you want to do this for 5 minutes and see if you can, derive the quadratic formula on your own. But then you can go back, start all over again. All right, so that takes care of that. More conversations we're starting. So let's talk about absolute value. And then this video is almost done. Do I still have to get the trig? Is the trig on the back side? No. All right, well, I do the trig. They never put it anywhere. Well, I will. I want to get some definitions going, so I'll erase this board in a moment. Get this TV out of the way. All right, back at it. So the absolute value of x is coming your way in a moment. Right now we're starting with y equals x. Just put some random values. X equals y, x equals y. I guess I was getting ready for the absolute value by writing a 4 instead of a negative 4. Okay, now we're up and running. So what's absolute value do? Absolute value measures distance from 0 on a number line. How far is it from 0 to 1 on a number line? 1 unit. How far is it from 0 to negative 4? 4 units. Distance is always positive. So if I slap an absolute value on this, what happens to my y values? They become positive, and we get a change on one part of the linear function here that we had a moment ago, and which is centered at 0. Okay, so what does that tell me? Now, whatever's in here, I better make 0, because that's where this change of sign is going to occur. All right, for instance, if I had x minus 4, absolute value of x minus 4, for instance, then when I put numbers bigger than 4, I get positives. When I put numbers less than 4, like 3, I get negatives. But if it's absolute value, what happens to the negatives? They become positive, and we get that V-shaped graph, and it's centered on the x value that makes a 0 inside that those functional symbols. All right, so one thing that we've been establishing here in the first 5 weeks, and if we're talking about patterns, there is one in front of you. I doubt very much that you've put it together yet, but I'd like to at least mention it. We're basically writing functions, multiplication and addition and subtraction. All right, we got a multiplier, addition and subtraction, and we've been graphing and working with all kinds of situations when we make what? F of x. This is the argument here. It could be more complicated, but generally speaking, our major function, right? We've been making 0 and 1. We've been making zeros and ones out of that part of these equations. Because what is m times 0 plus c, and what is m times 1 plus c? Easy calculations. Right? If you make it 0, well, then you're getting C, and if you're making it 1, then you're getting M plus C. Places on a graph, and places on a graph start to give you a feeling for numerical trajectory. Like so. Just mentioning that as well. All right, so let's see if we can graph this and write it as a piecewise function. So I got positive 2, just like quadratics. V shapes up. If the multiplier is negative, V shape down. So that's established. This one is V shape up. What makes a 0? 3, very similar to the quadratic. 4. Right. Where does the hinge take place? At x equals 3, because that's what makes a 0. In this case, where 3 is critical, if I put numbers bigger than 3 in, and I make this a linear function, right, then what do I have happening at 3, 4? One side is coming down, one side is going up. So one side is coming down and one side is coming up. So the multiplier is what gives you slope. If this had been a 5 in here, then the hinge would have been at 3/5, and the slope wouldn't have been 2 anymore, would have been 10. That's going to be coming your way as well. But right now, we're going to leave it on a little simpler model. We have a decreasing coming down on this side, going up on that side. Now, why is that helpful? Well, that's helpful because now I can solve these equations very quickly. Maybe there's a faster way. I think there is, but it takes a little conceptualization, whereas this takes no thinking. Given the original function, however complicated the argument becomes, if you simply put a plus minus in front, you've got 2 equations, and they're linear in nature, which means the inverse operations are generally a piece of cake. So, and there are shortcuts to this process too, but let's not take any shortcuts right now. Let's solve one of these for the minus side, the decreasing side, and then let's solve the other one. And you might even see where the shortcuts are in this process without me telling you. All right, so what do we got? We're subtracting 4, there's 16. We're dividing by -2, there's -8. And I'm adding 3. There's -5. -5 should work in this problem. Let's take a look. -5 minus 3, -8, the absolute value -8. 8 times 2, 16, plus 4, 20. That works. Let's do this one. Let's do 16. Let's divide by 2. That's +8. Oh yeah, sign change. And then let's add 3, that's 11. Let's check 11 out. 11 minus 3 is 8. We're right back where we were a second ago. 2 times 8 plus 4, 16. All right, let's put those on a number line. Let's look at this on a number line. Let's see, what are the critical numbers? -5 and 11. Notice I did not put 0 down here at all. Those are the 2 critical numbers for this equation. Okay, but let's add these up. -5 plus 11. And let's divide that by 2. Let's take the average. Oh, that's 6 divided by 2, which is 3. Oh, geez, must be a coincidence that the average. Oh, maybe it's not a coincidence. Maybe there's some symmetry here, giving us that x value for an average. Yeah, as I look left and right, it sure seems like it's centered there. All right, that's just a quick check to make sure you didn't make a careless error. All right, why is this helpful? Why is finding those 2 numbers helpful? Because I could change this to an inequality. And I could say, well, when is this bigger than 20? Yeah, well, I know the numbers that make it 20. So if I'm not mistaken, there's 3 intervals, A, B, and C here. There's numbers between -infinity and -5. There's numbers between -5 and 11. And there's numbers bigger than 11. And what you'll find is that your answers alternate for absolute values. So all you have to do is pick one number, get all of this out of here, everything else that I don't want you to be thinking about right now out of the picture. All right, and all we have to do is trial and error. Let's pick a number bigger than 11. I'll pick 1,000,000. Oh, 1,000,000 is way out here. All right, 2 times a million plus 4. I don't think I have to subtract 3 from a million in my head. Positive a million. All right, absolute value, it's going to stay positive. Multiply by a positive, add a positive. All right, that's 2,000,004 roughly. I think that's bigger than 11. True. False, true. All right, so now the question is, how do I communicate this to you easily? Well, that's called interval notation. Because I'm looking at intervals. Interval, I'll just put it n there. All right, so you're used to writing from grade school, I think, let's make that 7. I hope you would say that's x greater than 7. And if you put a, colored in that, then it's greater than or equal to 7. And some folks, let's make that a 3, then that is x is less than 3. All right, some people have a little trouble with the word and or. All right, a number can't be greater than 7 and less than 3. It's not possible. Right, so we use the word or. But we can avoid all of that by learning how to write interval notation. So this is going to negative infinity, which has no bound. So I'm using a parentheses, negative infinity. And I'm going to go to 3. And because it's open circle, I use a parenthesis. Versus, I'm going to use this symbol to say also for right now, bracket 7, because I want people to know that 7 works in this equation. If I had written greater than or equal to, they both, right? But I'm just, this has nothing to do with this problem here at the moment because I'm working with those numbers. But this picture goes to positive infinity, and that can't be bounded. All right, so that's going to be something we talk about the rest of the semester. And you can you're going to get the first look at that in class later, and you're getting another look at it here. So how do I write this answer? For this equation, negative infinity to negative 5. Negative 5 doesn't work. Union 11 doesn't work. To infinity. That's interval notation. People pick up on that pretty quickly. So we'll just let that happen over the next few days. Now, if all of a sudden I put the equal sign here, then negative 5 works, so it becomes a bracket, and 11 works, bracket. Now we have interval notation. And the last thing I wanted to get started with today is just a couple of definitions for some simple trig functions. And we'll have to start working with a lot of geometric representations in the next few weeks, but let's just get the conversation started. All right, so now you've been working with Pythagoras for quite a while, and if I tell you that that's 3 and that's 4 and it's a right triangle, you should be able to tell me what that length is. This is a famous ratio anyway. All right, so hopefully you're getting better at 9, 16, and the 2 smaller sides add up to the area of the larger, and this is a square root, so I would hope you'd say 5. Most of you in class would now do that. And so let's highlight that triangle again. And I'm going to put it in a coordinate system this time. And I'm going to call that angle A. This side length is 3, this side length is 4, that side length is 5. And I'm going to define this function for you by just writing some truisms. The cosine of angle A is equal to 3 over 5. The sine of angle A is is equal to 4 over 5, and the tangent of angle A is equal to 4 over 3. Now you can pause the video and look at that, and you can process that, I think. All right, so let's start with what most people start with is the sine function. Although I think it would be historically better if we started with cosine and then sine, but I'll talk about that later in future discussions. So I think you have to get a sense of positioning here. Where is this side in relationship to angle A? All right, angle A is less than 90 degrees, right? I mean, it could have drawn a circle here and gone 360. But, so it looks to be more than 45 because it's higher than this one. If they were both 4s, then it would be a 45-degree triangle, so it's a little more than that. But the question is, where is it in reference to angle A? What appears to be opposite angle A. That's opposite angle A. So the sine function, you can start thinking about as opposite over, I think there's a name for this that you should have learned in probably 3rd or 4th grade, hypotenuse. Okay, so if you see the command, the sine, then you're looking for the opposite side divided by the hypotenuse in a 90-degree triangle. We're after 90-degree triangles, a right triangle true. Okay, what about the cosine? Well, it certainly is this side. And somebody had to give that side a name. So what do they call it? They called it the adjacent side. Okay, so maybe I should just put that over on the side here. So we got we got some kind of generic triangle. We got an angle drawn in standard position connected to the origin. So this is the opposite side to that angle. This is the adjacent side. And this is the hypotenuse. And now that we have that, I think you can tell me what the tangent is. The tangent is 4/3. So switching over here, I could have looked at the command, give me the opposite divided by the adjacent to this picture. Right? Opposite divided by adjacent. And you got to memorize this stuff. All right? So you're getting your first look at it in a few hours. And then I assume you're looking at this tonight. And you're hearing it again. All right. My experience has been that if you do this 4 days in a row, most people can start to handle a problem like the following. I'll just make I'll just give you 2 situations. And we'll practice it just one time. Let's say that x equals 5 and y equals 3. Can you find the cosine of angle A if drawn in standard position, the sine of angle A if drawn in standard position, and the tangent of angle A if drawn in standard position? X and Y are positive in the first quadrant. You can pause the video, try it on your own. I'm just going to do it here. So there's X, 5, there's Y, 3. There's, I guess, a need to find that length. All right, so 25 and 9 is 34, so that's the square root of 34. So what's the cosine of angle A? 5/√34. What's the sine of angle A? 3/34. And what's the tangent of angle A? That was already given, it's 3/5. This is kind of like rise over run, a linear function, yes? Okay. All right, so now one other that we'll start practicing before we launch into further discussions and where this takes us. Because we're almost getting to the point where we can start to do these in 10 seconds or less. We're getting there. I'd say about 3 weeks from now, some of you will be doing those nicely and easily. All right, so let me give you another one. What if I didn't give you the y value? Let's say I give you 7. I don't give you the y value, but I give you the z, which is going to stand for our hypotenuse of 10. All right, you pause the video and you give it a try because you've been practicing how to find these values in the last couple of weeks on tests. All right, so what have I got? 100 minus 49, square root of 51. But let's draw it out anyway. 7 to 10. That's 7. That's 7 units. That's 10 units. Okay, and yeah, it's pretty close to a 45-degree triangle, so I should have drawn it a little bit better. But that's 100. Yeah, that's 100 units of area. That's 49. So 51. So this is the square root of 51. All right, so I'll put that over there now. Let's get a picture. Square root of 51 we just found. Righty, so here's the picture. Got a much better picture now. That's better. Square root of 51, 7 and 10. All right, so let's do cosine of angle A, sine of angle A, and the tangent of angle A. All right, so cosine is 7/10. Sine is root 51/10. And tangent root 51/7. Okay, and now we have some new material that we can start tackling on our worksheets. And those of you who are moving a little faster than others will be good tutors in 2 weeks for the other folks who are, going to take a little longer to get there. All right, so good citizenship. You're going to help some people out in a couple of weeks. And we'll move all boats will rise. Okay. That's enough for that. See you in class in a couple hours. Well, you're watching this tonight, so well, however I want to phrase that, I don't know. Ta-ta.